Welcome to the Omnia II video series. This series of videos will introduce you to the Associated Research Inc. Omnia II instrument. The Omnia II is our flagship electrical safety tester with the capability to perform ground bond, DC continuity, dielectric withstand, also known as the high pot test, insulation resistance, functional run, and line leakage testing. Additionally, the 8207 and 8257 instruments come standard with a built-in 500 VAC power supply. This provides stable, clean power to the device under test for functional run and line leakage tests. Before we get started, it's important to remind you that you're dealing with an instrument that has the capability to output high voltage and high current. That being said, all necessary safety precautions should be taken before you use this instrument. It's recommended that the user read the operation and service manual before using the Omnia II instrument. First, we're going to go over the Omnia II front panel controls. First and foremost, the power switch, which will turn the unit on and off. The test and reset keys are used to stop and start tests. Additionally, the reset button is going to allow you to clear a failure so that you can run an additional test. The Omnia II also comes with a color TFT display. The Omnia II also has soft keys, which allow you to make selections and get to various menus on the screen. The alphanumeric keypad is used to enter textual or numeric data. The arrow keys will allow you to navigate menus and system and setting parameters. The My Menu key is a new function on the Omnia II, which allows you to make your own custom menu. The Exit and Enter keys will allow you to cancel or confirm inputs respectively. The scanner status LEDs will light up to indicate the status of a scanner channel if you have a scanner connected to your Omnia II instrument. The unit also has a caution and high voltage light indicators to show you when a test is being run and there is a shock hazard to the user. The high voltage terminal will output high voltage to the device under test when you're running a high pot or insulation resistance test. The current port will actually output high current as well as low DC current for the ground bond and DC continuity test. The Sense Plus and Sense Minus ports are used for what is known as a 4-wire Kelvin measurement. What this does is it senses the voltage drop across the circuit and allows you to negate the resistance of the test leads. And finally, the return port is going to be your return path for your ground bond, DC continuity, high pot, and insulation resistance tests. Next are the rear panel controls. The calibration button is used to put the instrument into calibration mode. To put the unit into calibration mode, push and hold this button while simultaneously turning on the power switch. The scanner connector is used for connection to an Associated Research Inc. SC6540 slave scanner. The Omnia II comes standard with 2 scanner connectors to allow the Omnia to control up to 2 SC6540, 8 high voltage, and 8 ground bond channel scanners. The remote signal I/O output is a 9-pin D-sub miniature female connector which allows the tester to monitor pass, fail, and processing output relay signals. The remote signal input is a 9-pin D-sub miniature male connector for remote control of the test, reset, remote interlock disable, as well as memory selection bits. These relay signals are dry contact closures. This means the unit does not produce voltage or current from the relay's contacts, nor is voltage signal necessary to set the bits. The bus interface is used for interconnection to the USB or RS-232 interface. Optional IEEE 488 or Ethernet interfaces may be substituted for the USB or RS-232 interface. The bus interface allows the user to fully remotely control the instrument via a PC as well as collect test data from the unit. The chassis ground connection can be used to connect the chassis of the instrument to a good earth ground before operation. The input power receptacle is a standard IEC 320 connector for connection to a standard NEMA style line power cord. The fuse receptacle is used to change the fuse. To change the fuse, unplug the mains cord and turn the fuse receptacle counterclockwise. The fuse compartment will be exposed. Please replace the fuse with one of the proper rating. The fuse that comes standard with the Omnia II instrument is a 10 amp slow blow 250 volts AC fuse. The Omnia II also has a second set of output terminals on the rear. The rear output terminals are connected in parallel to the front panel connectors. This gives the user flexibility to connect their device under test using either the front or rear panel outputs. The DUT power input connector provides the line and neutral input power connections on pins 1 and 2 respectively. An external single-phase unbalanced AC power supply with a single hot and line conductor should be connected here to supply power to the DUT while performing line leakage and functional run testing. The input is rated from 0 to 277 volts AC at 50 to 60 Hz. The line and neutral output connectors are used to attach the adapter box high voltage test leads to the instrument. Line power is supplied to the DUT during the line leakage or functional run test through this connector, and high voltage is supplied to the DUT through this connector during the dielectric withstand or insulation resistance tests. During a dielectric withstand or insulation resistance test, the line and neutral terminals are shorted together. The case connector is used to attach the return lead to the DUT case or chassis. This provides a return path for the ground bond, DC continuity, dielectric withstand, and insulation resistance tests. During a line leakage or functional run test, this terminal is isolated from the test circuits. The ground connector is used to attach the adapter box ground or earth lead to the instrument. The probe high and probe low connectors are used to attach the probe high and probe low test leads to the DUT. When used with the appropriate test leads, these terminals connect one side of the measuring device to the DUT during enclosure, touch, or patient leakage testing. These terminals will be enabled during a line leakage test whenever probe high to line or probe high to probe low has been selected. When a functional run test or line leakage test is not being performed, these terminals are isolated from the line leakage or functional run test circuits. The external MD contains an external measuring device PCB that will enable during a line leakage test when external is selected in the line leakage parameter window. The external MD allows the operator to configure a custom measuring device. Next, we're going to cover the Omnia system settings. These are the global settings for the instrument that allow the user to set the instrument's time, date, calibration settings, instrument hardware, security, and user interface preferences. Upon power-up, the Omnia automatically defaults to the main menu screen. From the main menu, press the Setup System soft key. The Setup System screen will now be displayed. From the Setup System screen, 5 different hardware and software controls may be accessed: time and date, calibration alert, hardware, security, and user interface. First, we're going to set up and make sure that the time and date settings are correct. From the Setup System screen, press the time and date soft key. The time and date settings screen will now be displayed. To set the date, simply highlight the Set Date parameter by using the left and right arrow keys. Select the field you want to edit. Using the numeric keypad, enter the new number. Press Enter key to accept the new number and the Exit key to escape from the edit. Setting the time works in much the same fashion. Simply use the left and right arrow key to select the necessary field and use the alphanumeric keypad to set a value. Press Enter to accept the edit or Exit to escape the edit altogether. To set the day, press the Set Day soft key. As the soft key is pressed, the Set Day pop-up screen will appear. Use the up-down arrow keys to select a day. Press Enter to accept the edit. Select the date format, simply press the Date Format soft key and select your desired date format. Press Enter to accept. To change the time format, simply press the Time Format soft key to toggle between 12 and 24-hour time format. Now that we've set the time and date on the unit, we'll want to set the calibration alert. The calibration alert is a feature that will allow the instrument to give an advanced alert that the calibration of the instrument is coming due. From the System Setup screen, press the Calibration Alert soft key. The Calibration Alert settings screen will now be displayed. The calibration date, calibration due date, and calibration alert date are all set at Associated Research prior to shipment. All units are calibrated before shipping and are provided with a calibration certificate. It is recommended to use the default settings and have the alert date set to 30 days before calibration is due. Associated Research Inc. recommends calibration on a yearly basis. The calibration alert can be set on or off by pressing the Calibration Alert soft key. Pressing the soft key will toggle the alert between on and off. The Omnia comes equipped with some unique hardware features. To access the hardware menu, press the hardware soft key from the Setup System screen. The hardware settings screen will now be displayed. Depending upon the instrument build, certain hardware options may or may not be available. For example, since the 8204 instrument has no DUT output, there will be no DUT HV setting on that instrument. The Smart GFI, or Ground Fault Interrupt Circuit, is an Associated Research Inc. patented feature designed to protect the operator from a potential shock hazard. The high voltage power supply of the Omnia is internally referenced to earth-ground. Since the leakage current measuring circuit of the instrument monitors only current that flows through the return lead, the possibility exists for current to flow directly from the high voltage output to earth-ground without being measured. The Smart GFI circuit monitors the current between the high voltage output and earth-ground. Therefore, if the operator touches the high voltage lead and earth-ground, the instrument will detect this hazardous condition and shut off immediately. Smart GFI goes beyond a standard GFI circuit by automatically determining the return configuration of the DUT and enabling or disabling depending upon the configuration. When the Omnia's return lead is floating, the Smart GFI circuit enables, protecting the test operator for electrical shock. When the Omnia's return lead is earth-grounded, the Smart GFI circuit disables, and the instrument operates in a ground return mode. In the hardware settings screen, highlight the Smart GFI parameter. Use the numeric keypad to set the milliamp value of the Smart GFI. The Smart GFI can be set to 0 for off, or adjusted from 400 microamps all the way up to 5 milliamps. Setting the GFI to 0 will only disable the ground current failure detectors. It does not disable the capability to externally earth-ground the return lead. The PLC remote setting allows the user to operate the Omnia in a remote mode using the remote I/O on the rear panel of the instrument. From the hardware settings screen, you may turn the PLC remote on or off by pressing the PLC remote soft key. When the PLC remote is turned on, the front panel test button is disabled and a test may only be started through the rear panel input-output. If you attempt to start a test from the front panel test button when the PLC function is turned on, a pop-up message will warn the user that PLC remote is on. If you have an 8207 or 8257 instrument, you'll have the option to set the internal 500 VA power source for the line leakage and functional run tests. From the hardware settings screen, you may turn the AC source parameter selection on or off by pressing the AC source soft key. When the AC source is turned on, the 500 VA power source is available for use during the line leakage and functional run testing. An additional set of parameters will be available in the run and line leakage parameter settings screen. The Omnia II gives the user the capability to select the measurement method for the dielectric withstand test. From the hardware settings screen, press the measurement soft key. As the soft key is pressed, the measurement method will toggle between true RMS and average. If you have an 8206, 8256, 8207, or 8257 unit, you will have access to the DUT/HV setting. The DUT/HV selection activates an additional parameter in the AC or DC withstand and IR test parameter screens. The additional parameter is called DUT output, and its function is to control high voltage relay at the DUT output. When the DUT output parameter is turned on during the AC or DC withstand and IR test, high voltage will be present at the DUT output as well as the front and rear panel output terminals. When the DUT output parameter is turned off, no high voltage will be present at the DUT connectors, only from the front and rear panel outputs. Press the DUT HV setup soft key and this will toggle the DUT HV setting between on and off. Selecting the DUT HV to off will prevent the parameter from appearing on the AC or DC withstand and IR test parameter screen. Next, we're going to cover the security feature. The security feature allows the user to set up a system of usernames and passwords to bar other users from certain menus on the Omnia unit. From the System Setup screen, press the Security soft key. The security screen will now be displayed. Selecting Security to off disables all security features and user ID settings. Selecting Security on restricts access to the parameter settings. The level of security is determined by the user setup function. From the security screen, press the User Setup soft key. As the soft key is pressed, you will be taken to the User Setup screen. Here, you can set up a user, password, and level of access. You can also view the list of users currently set up, as well as their associated security level. The Omnia will have a default user ID named admin with full system access security level. This user ID cannot be deleted. To set a new user, press the Add User soft key. As the soft key is pressed, you will be taken to the Add User screen. Use the alphanumeric keypad to enter a username, password, and desired security level. The final available selection from the System Setup window is the User Interface. From the System Setup screen, press the User Interface soft key. From this screen, the user can set the test failure alarm volume, step name, language with a choice between English, Chinese, and Simplified Chinese, as well as the color style for the TFT color display. You can also select what screen the unit will default to upon power-up. The user can choose between Menu, Perform Tests, and My Menu. The user can also select if they'd like the animation to automatically continue, pause and wait for user input, or skip the animation entirely. Not every product terminates in a 2 or 3 prong line cord. For devices that require a different connection set, test leads may instead be utilized. First, plug the black return lead into the return terminal on the front or rear panel and the black Kelvin lead into the sense minus terminal. Then, connect the high voltage lead, terminated in a red clip, into the HV terminal on the front panel of the instrument. Attach the clip terminated end to the return lead to the case or chassis point of the DUT. If you're performing a ground bond or DC continuity test, connect the red high current lead into the current terminal and the red Kelvin lead into the Sense Plus jack. The clip at the other end will connect to a grounding point on the DUT. So far, we've covered the rear and front panel connections, along with global settings on the Omnia II instrument. The last part of this video will demonstrate how to connect the adapter box and test lead connections. This section of the video will outline how to connect the adapter box to an Omnia instrument. The adapter box is an easy way to connect a DUT that terminates in either a 2 or 3 prong line cord. First, we're going to have you connect the black case lead. Attach the black case return lead to the case terminal. Next, using the adapter box, connect the line lead from the adapter box into the L terminal and the neutral lead into the N terminal. These two types of terminals are twist lock, so simply push in and turn to the right to lock into place. Next, take the ground terminal, use the hook lug to put onto the ground post, and turn to the right to lock shut. Finally, if you're making patient or enclosure leakage measurements for a line leakage test, use the probe high and probe low terminals by plugging in 2 high voltage leads. This video has introduced you to your Omnia II series instrument. In the next video, we're going to cover how to set up a test, attach your DUT, and run a sequence of tests. Thanks, and join us next time.